Hello friends, in today's class we are going to talk about disk scheduling algorithm. Welcome here, and we are talking about disk scheduling algorithms, and there are many requests come for the disk IO. Okay, so there are many requests for disk input output, and how these requests are served by the disk. Okay, so how to satisfy the disk IO request, and that we are putting in, and that is done by the different algorithms, and that we call it as a algorithm. Okay, so now here, okay, so there should be some criteria. The operating system is responsible for using the hardware efficiently for the disk driver, and this means having a fast access time and the disk bandwidth. Okay, fast access time and disk bandwidth, and here in the fast access means minimizing the seek time. Okay, so first the head need to position at beginning of the sector that it read. Okay, beginning of the sector it read, and that time is called the seek time. Okay, that time is called the seek time. And minimizing seek time means minimizing the seek distance. Bandwidth is something that is a number of bytes transferred per unit of the time actually. Okay, the bandwidth is the total number of bytes transferred divided by the total time, okay, between the first request for service and the completion of the last transfer. Okay, first request of the service and the completion of the last transfer. The bandwidth is something bits or bytes per second. There are many sources of IO requests, and operating system can have a IO request, system process and user process can have the IO request, input output request. So the disk scheduling is, note that the driver controller have the small buffers that can manage a queue of IO requests, means because there are several operating several system process, operating system process, user process are waiting for the IO, so it can make a very small queue. Several algorithms exist to schedule the servicing of IO request. The analysis is true for one or more platter. Okay, so even if the platters are more in this, okay, and in that case this analysis is true. We illustrate algorithm with a request queue. This is my request queue: 98, 183, 37, 130, 122, 14, 124, 65, 67, and the entire cylinder is numbered from 0 to 199, and the head pointer is at 53. Okay. So first we are going to talk about the first scheduling algorithm with FCFS, which is having the request and head is at 53. So 98 is the first one, and here this part is the moment, and this is our total number of head movement. Okay, this is our head movement, total head movement in this. So this is your total head movement. Okay, so 90 is the first one. Second one is 183, which is causing 85 head movement. Then 37, there is 146, then 122. Then we are getting to 14, and then we are going into this 124, and then again 124 to 65. Remember that we do not have a negative one, means I need the modulus value, but I did not put any sign. Whether it is a left movement or right movement, there is a movement. Okay, so left and right both, there is a movement of this head. Then 2. Illustration shows the total head movement is 640 cylinders. Okay, so 646 or 640 cylinder, and that is sum of two. This value which is nothing but 45 plus 85 plus 146 plus 85 plus 108, 110, 59 and 2. The first come first scheduling policy is very simple, that in the first whatever the request is coming, and that order we are going to serve them. Okay, so that is first one. Shortest seek time first, and the same order the requests are coming, and the head is at 53. Okay, shortest seek time first scheduling algorithm. Select the request with the minimum seek time from the current head position. Okay, the criteria here is the minimum seek time from the current head position. SSTF scheduling is a form of SJF that may cause starvation of some request. Okay, and we know that SJF is true as SJF is not possible. So 53 is there, and we have to look at the future, and the 53 to 65 is the shortest one. There's 67, and then we got 37, the closest to 67, and then we got 14 closest to 37. Finally I got 98, which is closest to the last request, that was at 14, and then we got 122, then 124, and finally 183. Okay, and that is giving this head movement 59. If you go and again sum up this value, shortest seek time 12 plus 2 plus 30 and so on, and this illustration shows that the total number of head movement in this case will be 236. Okay, so there total 236 head movements will be there. So that is your first two algorithm, and here the idea is very simple, that here you have to go by FCFS manner, and here we have to go for the shortest seek time first. Okay, the next one is scan or elevator algorithm, and the disk arm start at one end of the disk and moves towards the other end, serving the request until it gets to the another end of the disk, where the head movements reversed and the servicing continue. Okay, so that starts with one end of the disk, move towards the other end, servicing the request until you get to the other end, and so you back and forth movement, something like this, and this movement will be there, and in between we will be servicing. Scan algorithm, sometimes called the elevator algorithm. Okay, and this says that the total illustration shows here that 236 cylinders. But note that if the requests are uniformly dense, largest density at the end of the disk, and those wait for the longest. Okay, so yeah, uniformly dense, largest density will be at the end of the disk, and those who wait for the longest. So at the end of this one, we have to wait for the longest. So we are moving to the one end, and 53 to 37, and then 23, and then finally we'll reach to this 0, one end of this, serving towards this, and we are moving toward the left, and then we move to 65, then 67, then we move to 98, then 122, then 124, and finally 183. Okay, so we are moving into the one end. Let's after seeing this one more time, let's see this. The disk arm start at one end of the disk and move toward the other end, servicing the request until it gets to the other end of the disk, where the head movement reversed and servicing continues. Okay, so this is the idea of this, and if you just add them up, that will be 236. So this is a scan moving into the just main point to remember, that moving into one end of the disk. Okay, it is just moving to one end of the. Okay, C-scan. C-scan provides more uniform wait time than scan. The head moves from one end of the disk to other, servicing the request at its port. When it reaches to the other end, however, it immediately returns to the beginning of the disk without servicing any request and the return train. Okay, treats the cylinder like a circular list, and that wraps around at the last cylinder by the first one. Okay, so this is a C scan, circular scan. That is a scan, but after servicing the last request, immediately returns to the beginning of the disk without servicing any request on return time. Okay, so that is your circular scan, and this is how the figure will look like. But let's read it out. 53 to 65, and then we have 67, and then we have a 98, then we 122, then 2 124, then 183, then we'll go to the end. Okay, and then immediately we'll return back to this 01 without servicing anyone, then finally 14, and then 37. Okay, and if you include everything, the head moment in this case will be 382, the 382 total cylinder movement. So it's same as scan that moves into the one direction, and we have seen it is moving into the left direction, and then it will return here in this is the scanning, like here, to move back and forth. Circular scan immediately come rather than servicing anyone in returning back. Look, okay, look is a version of scan, and the C scan, C look is a version of C scan. Arm goes as far as the last request in each direction, then reverses the direction immediately without first going all the way to end of the disk. Okay, so here one thing is that what we do is in the C scan and this scan, that we reaches to where? We reaches to the end of the disk. Right? We reaches always to the end of the disk. Here 14 to 0, then we will reach all the way to the end. See, look, in this also we started here, and then we reaches to this end, and then finally we move back, and then we provide this. Okay, so that way the C, but C look is what? It goes, like here it goes in this way, in one direction. Go to the one direction, no issue with that. And then finally you don't move from here, but rather than you come back to this 14, the last request, and then 37. Okay, circular look. And the total illustration shows that the head moment is 322. Okay, so that is your C look method, and very simple way. Your arm goes as far as the last request in the each direction, and then reverse the direction immediately. Okay, so that's all for this discussion of disk scheduling, and I hope you understand this, and let's solve few practice questions based on this. Thank you. So the scan or elevator algorithm is our next disk scheduling algorithm, and it says that the disk arm start at one end of the disk and move towards the other end, servicing the request until it goes to the other end of the disk, where the head movement is reversed and servicing continue. Scan algorithm is also called as a elevator algorithm. So now when as you can see here, that elevator goes up and then it goes down, the same way it goes in one direction and servicing all the requests, and then it will come back. Here when we are using a scan, the direction is important, and suppose the head is moving into the, like here it can move to both directions. So since the head is at 53, now it can move to lesser value or larger value, but here I'm assuming that we are moving into the lesser value, and that will be given to you in the question that it is moving to the lesser value. 53, we are moving into the lesser value, so that is your 37. The next lesser value will be, in this case, is after 37, the next lesser value is 14. Okay, sorry for this. Next lesser value is 14, so that will go to the 14. Then all the way it will go to 0. Okay, all the way it will go to 0, it will reach to the one end. And then it will move to reverse the direction here after servicing it, and the reverse direction will be here up to where 53 has been done to 65 will be the next that it will serve, and then it will move to 67, that is the next value, and after 67 it will move to 98, that it will serve. Finally it will move to the next request on that direction is 122, and then it will move to the next one as 124. Finally it will move to 183, and that ends its movement. Okay, so we have assumed here that this movement was in this direction, and for the lesser value. Okay, and then it comes here and then change the direction movement to the right. Okay, now this algorithm shows the total movement. This illustration shows that, sorry, this is wrong. The total movement in this case is 236 cylinder, and that is how scan algorithm works. We have another variation of the scan is called C-scan, and that is your circular scan. Okay, circular scan, and that is a version that treated all the disk as a circular queue. Okay, and it provides the more uniform wait time than the scan, because wait time can be larger here, because if you're moving in one direction and if the density is more over here, then you go all the way to this and then you'll come back to this. Okay, so then more or less uniformity will be there in that case. The head moves from one end of the disk to the other, then servicing the request as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk. Okay, so now if start with 0, then again it will come back to 0 without servicing any request on the return track. It treats the cylinder like a circular list that wraps around from the last cylinder to the first one. Okay, so that is your circular scan, and again now this time I assume that it is moving into the right direction and moving to the larger cylinder, and that goes with 65 to this 53 to 65 while movement is 12, then 67, then 98, then 122, 124, 183. Now after that it will now reach to the end, like here in the previously it was reaches to the end of 0, it will reach to this 199. Immediately after this, reaching to this point, it will come back to this 0th position, and then it will go for the 14 and then 37. Okay, so in the returning back here, and it will be servicing all this. So that is your C-scan, circular scan, and more uniformly in terms of if there is a more or less wait time, more uniform and less wait time. So it's more uniform and less wait time. Okay, so the next algorithm here is your look algorithm. Okay, and this illustration shows that total 382 cylinders movement. Okay, if you add it up, that will get the 382. Okay, so the next one is your C look and look. Look is a version of scan where we move to the direction you have to specify. Okay, understand that we need to specify the direction, lesser values of cylinder or higher values of cylinder. But here in the look, but all the way we go to the end, and then we immediately come back in C scan, and in the scan we while coming back we serve all this thing. Here look is a version of scan and C look is a version of C scan, circular scan, and arm goes as far as the last request in each direction and then reverse the direction immediately. If you look at your arm goes directly till your last one. Okay, this goes till this here, and if you look at your scan algorithm that was reversing, it was also going till the end here. But here in this case, in C scan and C look, and that arm goes to the last request, reverse each direction, and then reverse the direction immediately without going all the way to the end of the disk, without going all the way to the end of the disk. So in one case is 0 we end, and one case is 199 we reaches, and without going all the way, it reaches here in this. Okay, so now the head moment here in this case will be 53 to 65, and then 67 I'm moving into the larger cylinder number, then 98, then 122, 124, then 183, and then it reaches in the previous C scan, it reaches where? Here in that case it reaches here. to the end, but now here the direction will be reversed immediately. Okay, and it will go to the, rather than moving into the 0th one, now it will move to the last scan, that is your 14. Okay, and then it will move to 37, and it will, and this is your circular look. It won't go to the this boundary. Okay, even when it is returning, servicing the last request, coming back to this one. Okay, so that is your C look, and again repeating that arm goes as far as the last request in each direction. Okay, arm goes to the last request in each direction. Okay, so that's all for this scan and C scan, look and say look.